So a few weeks ago, I made a video on how to switch your power in iNav with VTX logic conditions. And this was done using a combination of the distance from home and the altitude. Well, now with iNav 2.6, we can do this even better. So let's head over and have a look at what's changed and what we can do to improve it. And most importantly, show you how to do it in iNav. So let's go. Okay guys, so we've got this diagram on screen, which I'm going to use to show how the older systems worked and how this new system is going to work. So let's, for our examples, say we'll make it really simple that we've got a VTX that will switch at a kilometer from low power to high power. I know obviously there's 4 different power bands, but we're just going to make things simple in this explanation. So the way the original tutorials did it before my last tutorial is they used distance from home, which is this distance along the ground. So if you're less than a kilometer out, it will be on low power. If you go over that kilometer, then it'll be on high power, which is fine if you're flying, just in a straight line, maybe quite low. But there are some people, in some countries, they don't have strict rules. They may choose to go 500 meters out, but a kilometer or 2 in straight up in the air. So if that's the case, they would still be on low power, but there would be that distance away from them where it's not causing the switch. So the solution that I came up with in the last video, which we'll do in red, was to take the distance from home, but also add the altitude. So by adding those 2 figures together, what we can then do is have a combined figure for that switchover. So if we're flying, say, a kilometer away, but also 500 meters up, that would add up to 1.5 kilometers. So it would switch over onto that higher power mode because we're going that extra distance away, or with that extra height. Likewise, if you're 2 kilometers up in the air, but 10 meters away, it would still switch to that higher band. But it's not ideal. We're limited in the logic conditions what we can actually do. So to actually get this working nice, we need to use Pythagoras' theory to get this distance here in orange, which we can now do because what's been added in iNav 2.6 is the Pythagoras is actually built in, and we just have a single logic condition variable, which will give us this orange line here. Right, so let's bring up a calculator and we'll see what's happening. So to work out the actual distance, we take the distance from home, which we'll say is 2 kilometers, and we square that, and then we add it to the distance here, which was 1 kilometer. So we need to do plus 1 kilometer, and we square that. And then what we do is take the square root of that. So this orange line here would be 2.236 or 2.234 kilometers rounded up. That is where our new logical conditions will get its data from. So that we can actually say is the plane is that distance away from us, regardless of whether it's up, down, straight out, straight up, whatever. And it also will work if you go down a hill. So I'll show a quick example of that. So let's say we're at the very top of a big hill. We're flying 2 kilometers out, or 1 kilometer down into a valley. It's the same thing. So what we want is our square of 1. We're going to add that to a negative 1 kilometer down, but we'll also square that, which gives us our 5 again, and the square root. So you can see it's the same calculation. So this is what we're going to do today, is this orange line here to give you the exact distance from the home point to the plane, wherever it is in the sky. And we can use that to switch our VTX. So let's get into iNav and I'll show you how it's done. Okay, so we've got our iNav 2.6. So you can see that up there. I'm actually running the alpha at the moment, or a compiled alpha. And what we'll do first is head into the programming tab. Now you'll notice that there's no longer separated logic conditions and global functions. They're all done on this single page now. So just be aware of that. And also, if you're importing old logic conditions and global functions. The logic conditions seem to come into iNav, but the global functions don't seem to appear on this page. So just be mindful of that. You may need to add them back in manually. So let's get into the actual programming itself. So first of all, what we need to do is create 3 logic conditions for how far away we are when it switches. So these all need to be greater than. They're all going to be flight variables. And they're all going to use the new 3D home distance flight variable. And that is the distance that I showed you on the diagram in orange. So now all we need to do is put in how far away we want to do the switch in meters. So the first one is going to be switching from the lowest power to the second. So usually that's 25 milliwatts to 50 or 100. So I think we can get away with maybe 250 meters for that. You should be able to do 25 milliwatts on 250 meters. And the next one I'm going to do at, well, I don't know, 666 just for the hell of it. It was Halloween recently. Actually, it's not been Halloween yet. It's Halloween in about 3 days, but when this video comes out, it would have been recent. And then finally, this is going to be when it switches on to full power. So maybe we'll put it a kilometer, but you can obviously tune these based on your local environment, your plane, your VTX, all that sort of thing. So what you'll have is less than 250 meters. It will be on the lowest power. Above 250 meters, it will be on power level 2, above 666 power level 3, above a kilometer, it will be power level 4. So now what we need to do is add a little bit of logic just to get the switches correct. So the first is going to be a not, and we're going to set that up to logic condition 0. So if we're not greater than 250, which is our first switching point, we'll be using logic condition 3. So logic condition 3 is our power level 1. And now we're going to add 2 more, which are exclusive ORs. And again, we're using logic conditions for both of these. So the first logic condition that we're checking is again number 3, which, number is 0, our first one, and then this will be logic condition 1. So for this to be active, it has to be one of these is true, but not both. So if we're greater than 250, then this one is active, so this will be fine. But then once we go over 666, this one will be active, which will actually cancel this out. So this here is the trigger for our power level 2. And the same with the next one, we're going to set this to 1 and 2. So when 1 is active at 666, that's fine. So, but once we get over the 1000, this one then disables. So what we actually have is logic condition 3 is power level 1, logic condition 4 is power level 2, logic condition 5 is power level 3, and logic condition 2, which is over 1000, is our power level 4. So what we need to do now is add what would have been the global functions to actually make these changes. So what we're going to do is enable 4 more, and what we need is in here to select our set VTx power level, and this will be, value will be 1, 2, 3 and 4, which will actually set our power level 1, power level 2, power level 3, power level 4. And now what we need to do is change when it's active. So this one, as I said, we need logic condition 3, logic condition 4, 5, and then finally logic condition 2. And then save. That's it, all done. So that's where I was going to leave this tutorial, but I had a comment on my last video on this subject from Mark, and he mentioned about the TBS VTXs that can have 5 different power levels. So what I was going to do now is show what you need to change to get those extra power levels. And basically you can set this up for as many power levels as you want, and all we really need to do is add or remove these XORs here. What we'll do, because obviously we're adding an extra power level, what we need to do is enable another greater than, use our flight and our 3D home distance, and then set this to, I don't know, 1.5 kilometers. So that's just basically adding another one of these in. So that's our distance here. So the furthest one away will always be the highest power level. What I should have done is added that down there so it'd be easier to see. But what we can do is go set power level, value, and 5. And this will always be, as I say, this top one here. So that will be logic condition 10. So what we also need to do now, because this is no longer the highest one on logic condition 2, we need to add another XOR function to go between number 2 and number 10. So what we do is we add another XOR logic condition, and this will now be 2 logic condition 10. Again, that's always active. So we change this one here to logic condition 12. I'm sorry, the ordering is terrible. What I'll probably do is reorder it so it's easier for you guys to see. But all we're effectively doing is adding in one of these for our distance, adding in one of these to go between the two different distances, and then we're updating our highest power level to be the furthest distance away. So that's all you need to do. If you want to add more, you could have as many as you wanted. You just need to add in the values here and add the XORs. And the same again goes for if you only, say you got the 5 position VTX, but you only want it to switch twice. Maybe you're happy with power level 1, 3, and 5. All you'd need to do is disable these. So let's say we'll disable this one for now. We'll set this one up for 1 kilometer. What we can do is disable this XOR here, disable this one, change this to power level 5, and that would now be logic condition 1. So let me just double check that. Yes, so that's disabled. So we have not condition 0, which is always going to be our closest. We have an XOR for in between two different distances, and then we have the final power level, which will be our highest power level on this chart. So what I'm going to do to make this easier to see is rearrange this page into blocks so we can see setting the lowest, then the repeated pattern for setting the intermediate power levels, and then finally the block for setting the highest. So I'll be back shortly and then we can take it from there. Okay, so I've rearranged this page now to give an idea of the different blocks that we're going to use. So this first block of condition 0 to 2 is for setting the lowest power level. So we have our greater than, our distance, and the 3D distance away that we want. So if it's lower than this, we're on power level 1. If it's higher than this, we'll be moving up to the next power level. So to make sure that it's lower, we just use the not statement and use logic condition 0. So if it's not greater than 250 meters away, it will then activate this, which sets power level to 1. So that's always going to be how your lowest power level will look. Then we have logic condition 4 to 6. We have another greater than, so this is going to be our intermittent distance, and this is how you repeat these for however many power levels you want. So if you have 5, you have 3 of these, but you basically, this greater than is going to be for each step. So perhaps this would be 500, the next one would be 750. So they're going to be your distances where it switches. And then each one will have an XOR statement. So the first logic condition will be the previous lowest distance. So in this instance, we're using 0 because that's 250 meters away. And then the turn off will be this one above it here. So if we had another one here set to, so for example, using 1,000 meters, the XOR statement on the next one would be logic condition 4 here and logic condition 8 here. So it's in between the two distances. And then just again, set the power level based on the XOR, but you can repeat these for each power level. And then finally, the last power level, which will also appear in the last XOR, is setting the distance where after that distance you want it at full power. So that's literally just going to be greater than distance and the actual distance in meters, and set the power level to whatever the highest power level of your VTX is. And then logic condition is going to be the number that greater than's on. You don't need any other logic for that. So hopefully that wasn't too confusing, because I think I confused myself while I was reading it out. But the way, if you want to know what the XOR statement is doing, just so that you can double check stuff yourself, is it's an exclusive statement. So it means that that can be true. So it will have, I'll save it. So that one can be true, or that one can be true, but they both can't be. So if they're both true or both false, this won't be active, but if one of them is true, then it will be. So because we're checking our lowest distance, if we're further away than 250 meters, this one will be true. But as soon as we go over this 666 meters, this one will also be true. So it will switch this off. So that's how it works to get those power levels going. So if we were separating it out, that would be 3, but there we go. If you have any more questions, please leave them in the comments and I'll try and get back. But I'm hoping that this is fairly easy to understand. But what I do is I'll rearrange it again, just showing how you do the 5. You've seen how you can do the 4. So hopefully with that, this layout here and the 5, which I'll do in a sec, you'll see how you can swap each one about. Okay, so I've rearranged it once again, this time grouping the different sets of logic together. You don't actually need these spaces. I've just added those so that it's easier to read. But here you basically have your distances. So less than 250 will be power level 1, between 250 and 500 power level 2, between 500 and 750 power level 3, and between 750 and 1,000 will be power level 4, and over 1,000 would be power level 5. So for however many power levels you have, you should have one less here. The same goes for the logic. The first one is the not, which, as we know from what we were talking about earlier, that's less, basically means that it's not greater than 250 meters. In other words, it's less than. So that will be your closest point. And then we have our 3 XOR statements, so to say between each one of these, and then we just use those to set our power level. So the not statement is the lowest power level. Then we have our 3 XORs here to set our intermediate power levels, and then logic condition 3, which is just the greater than 1,000, is used to set the highest power level. So I'm going to leave it there. I will have a video out fairly soon, because I was also requested to show how you can just do this with a switch on the transmitter. So I'll include 2 different ways of doing that, one using in-flight adjustments and another using the 6 position switch on stuff like Radio Master was actually what was requested, so I'll cover that as well. So what I'll do is I'll swap back to the original video now and wrap everything up. Thank you guys for watching. So there we go. Unfortunately, I can't demonstrate this because it's in meters and I can't move my flight controller that far. Even if it was 1 or 2 meters, I'd struggle. But this is all calculated within iNav. It works in the same way as my last tutorial, which worked absolutely fine. This is just computed itself, so you don't need to worry about it. And it actually gives you a more accurate distance between yourself and your model wherever it is in the sky. So If you found that video useful, I'd really appreciate a thumbs up. And if you haven't already subscribed, please consider it, because it helps get it out to more people so they can learn how to do this too. Thank you very much, guys. Fly your models like you stole them, if the weather allows it, and have a great time. I'll see you on the next one. Bye bye.